Thanks everyone for being here today. I am presenting the LOINxml Schema, design decisions and intended application. We are quite a few authors. I added our pictures on the right side, so grab anyone over the next or over the day if you have any direct questions. Because we don't have so much time, I will keep the motivation short. When we are working with, well, this is a bad example. This is what we don't want. When we are working with BIM models and digital twins, information requirements are important. We don't need to discuss this. What we have currently is usually semi-structured tables that, well, this is not the future. No one wants this. We also have additional checking. Obviously, you can also do this with IDS. But it also doesn't cover all the requirements that you might need for modeling. It also might add as an additional step of adding the requirements to the model and not having it being compliant with the requirements during the entire planning. Our chair, Sebastian, already mentioned this is a standardization topic. So our goal was to develop a schema, a data model for the level of information need. It is XML based, that's why it's called LOINxml. It is part of the standard 7817 series, part 3. So we know we need structured information requirements. They are good, we don't have to discuss this. We need them to be precise, and we need them to be able to be varied according to actors, milestones, all the prerequisites. We also need them to be usable during design, as I mentioned, and not just after it for checking. And we also might consider, one of the things that we did, not having it being dependent on only one breakdown structure is the official name for it. So this schema, this data model is compatible with IFC, but it is not limited to it. So you could use also CityGML or some other data structures to define object types. And we also tried as an objective to keep it lean, so that's where we get to the lake data topics. On a normative level, obviously we wanted to write a standard. We succeeded. The draft for ISO 7817 Part 3 was published in March. We have the comments already. And we also had the objective to harmonize with existing standards. So we don't develop definitions for properties or for object types that already exist and concur for, that's bad for the industry, right? In this harmonization, we noticed the data templates, previously known as product data templates. They were published last year. They also have a data schema. And we use a lot of elements from that because they align quite well with the intended use of the level of the information need. So among other elements, they define object types, properties, group of properties, dimensions, units, all things that we need when we describe information requirements. It is also aligned with ISO 12006. So we have this concept type, subject type, object types that are aligned with classification systems, with broader ones. So it makes the level of information need quite widely adaptable. So we thought, why not use it if it's so robust? It was closely aligned. For lack of time, I will not go over the broader normative context. Please check the paper if you're interested in that. Also, the methodology, how the standard was developed, is explained in the paper. Obviously, everything was tested, but I will not go into detail. I want to concentrate on the model itself to give an overview. And also a few examples. So the model, the data model has a lot of possibilities, and I will just illustrate a few. As I said, I will start with the overview. So we have the level of information need is the root. It has a specification. It can have more than one specification. You can add in the container more separate ones. And it consists of the prerequisites, so everything, always when we have information requirements, we have some context information, so we don't share them or define them without it. The specification project type, which is our core element, and the georeferencing, because usually when we have information requirements for a project, it also has this information, it's also needed. The specification project type kind of acts like a container, associating an object type to the alphanumeric information, geometric information, and documentation that were defined in part 1 of the standard series, the principles. One thing that we might want to remember is that we don't have levels anymore. The name is a little bit misleading. I myself think that it should be called model of information need, a MOIN instead of a LOIN. Would also be less weird with the acronym, but what we do is not define the levels, we define the information for different object types. And these object types can be anything in a project. So it can be, if we keep to the IFC, which we know, we don't have to, but we might. It can be something defining something on an upper level of like IFC project, but I also can define specific information for doors or walls or anything. And you can see in the cardinality that you always have to specify an object type, but all the other elements are optional. So I might just define alphanumeric information for walls, or I might just define geometric information. I might define all 3 of them if I need some schedule, or I get to the documentation later. And as an important thing, we have IDs, UUIDs for all elements within the schema. This will get important later. So the next time that someone asks me, yeah, but how do you map to IDM, or how do you map to IDS, I will shake them. Because we don't have to map, we can just link. For example, if you say, okay, I don't want to reinvent, I already use IDM to define, I don't know, my process maps or my use case. Perfect, continue using it. We have in the prerequisites an element that's called purpose. It has a dictionary reference, so you can reference with a URI, or a URI and a UUID. It is a 2-layer reference system to an existing IDM, if you have that, or an existing other local project management tool document that you already use. The object type. The object type also has a dictionary reference, so you can use the elements within the level of information need data model to define, to describe the object type. But if you already described it somewhere else, you can link that. You can link to the applicability of an IDS, for example. You can give the URI, the path, this is my IDS, and this is the IFC wall, IFC doors that I want to define. And maybe you can do the same. And additionally, you can also link to the SDD, other local databases, to data templates, if that's something that is being used. The same goes for the alphanumeric information. So you can also link to IDS requirements through the properties or group of properties elements. You can link to BSDD or local databases, but you can also use the data model to describe the properties and groups of properties inline inside the XML file. So it can be used as a standalone. I mentioned that it has, this is the part 3 in a standard series. So we have part 1 principles, like every series. Part 2 is guidelines. So the people working in the guidelines group, they thought about, that's a problem. They thought about different aspects that we use to cover geometric information. One of them is detail. So using the detail, you can reference to an existing LOD. But you can also use those aspects to describe, they developed decision trees that we implemented in the data model to describe the geometric information of your object type, if that is something that you want. Then we have the georeferencing, where we define a a model coordinate system and a coordinate reference system. Also here we have the option to link to a datum registry, an existing one, external one. But it's also, it doesn't have to, but we have to define the model coordinate system and the coordinate reference system with all, you can also define it in there with all the information that you need for that. And the documentation where you can describe required documents. So for an IFC project, I can say here I need drawings for all the project, or for my doors, I need some schedules or lists. And I can also link a reference document to say, hey, when I want a schedule or a door list, whatever, I want it to look like this, like from a past project. So what do we have? A lot of external references, but they are all optional. We can use the level of information need data model and do everything in an inline container, or we can do it with resources divided, I don't know, across everything. Our relevant design decisions were the integration with ISO 12006 part 3 through ISO 23387. This also aligns with ISO 23386. We divided the object type from the specification for object type. We have an identity for the information requirements. The requirements have IDs, so we don't have just the IDs for the instances later in the model, which it's nice. We also have the IDs for the requirements, so if they develop, if they change, we can also keep track of that. We have multilingual support, and the reference system is two-layered, so we can reference a URI, a path, and additionally an ID inside the file or table. It is agnostic. We don't just cover IFC. You can use IFC, but if you need to use something else, because the client, let's be honest, not everybody understands IFC so deeply that they are able to describe everything in there. But this shouldn't be a reason to not describe the information. Our conclusions are that the schema is very powerful, but behind ISO there is not a big marketing machine. So that's a reason why I'm here, so that we talk about the schema, use it because it needs wide support, software adoption, training. People need to understand how it is used, how it's supposed to be used, so that we have adoption and it doesn't just exist, but really gets its full potential. I hope I managed almost in time. Thank you for your attention. And